everyone, Om Swastiastu. My name is Putudea Krishna Pradnyautami with student ID 2511021013 from the Educational Technology Study Program at Universitas Pendidikan Ganesha. Today, I want to present a topic that is absolutely crucial to modern information technology infrastructure, building a local area network and wired network. Let us start with the core concept. What exactly do we mean by wired network? By definition, a wired network is a fundamental networking system that connects two or more computers using guided physical transmission media. In the real world, you can widely see this system utilized in print and photocopy shops for printer sharing, in school computer laboratories, and across professional office environments. From an efficiency standpoint, a wired network completely eliminates the need for users to physically swap USB cables or flash drives between computers because every device is seamlessly unified within a single network ecosystem. Even though wireless technology has become ubiquitous nowadays, wired networks remain the primary choice whenever performance is the top priority. There are three major advantages to a wired network. First, high stability. Wired networks are completely unaffected by external electromagnetic wave interference, ensuring a solid and consistent connection. 2. Maximum speed. The system supports constant and rapid data transfer rates ranging from 100 Mbps to 1 Gbps. This is significantly more stable than early wireless technologies, which were limited to just 54 Mbps. 3. Security and distance. It is highly secure and exceptionally reliable for both voice and data communication over longer distances, especially when utilizing specific physical media. To successfully build a local area network, we require several essential hardware components. First, we have the LAN card or NIC network interface card. This is the physical hardware interface used to connect computers within a LAN, and it comes built in on modern laptops and desktop PCs. Second is the hub, an internet connecting device that also acts as a signal amplifier for UTP cables. Hubs are categorized into passive hubs, which don't require external power, and active hubs, which use external power to boost the signal. Third, we have the switch. Unlike a simple hub, a switch is an intelligent device that manages and distributes data frames actively. It features address learning to record MAC addresses, frame forwarding to send data exclusively to the destination port, and looping avoidance to keep data from circulating indefinitely. Furthermore, we look at advanced hardware such as repeaters to extend signal range, routers operating at layer 3 of the OSI model to connect separate networks via static or dynamic routing, and access point, which serve as wireless terminals bridging mobile clients directly into our wired local network. Now, let's examine the media itself. There are three primary types of Ethernet cables. First, coaxial cable, a concentric cable with a protective metal shield and a single copper core, which used to be the old standard for TV antennas and legacy LANs. 2. Fiber optic cable, a Premium cable that glides like waves through internal refraction. It offers massive bandwidth up to 1 Gbps, reaches distance up to 200 meters, and is immune to magnetic interference, though it is the most complex to install. UTP cable or unshielded twice pair. This is the current standard choice for LANs, consisting of a color-coded copper wires twisted into pairs with an impedance of about 100 ohms. UTP cables come in several categories. Category 1 is for analog phones. Cat 2 supports up to 4 Mbps. Cat 3 handles early 10 Mbps Ethernet. Cat 4 runs up to 20 Mbps, and Category 5 serves as the baseline for fast Ethernet up to 100 Mbps. To connect these wires, we use the RG45 or register jack 45 connector, a clear plastic plug with 8 gold plate pins. Keep cable length limitation in mind for a standard length deployment. A UTP cable segment should be at least 1 meter long and must never exceed 100 meters. Exceeding 100 meters without active networking equipment triggers distance degradation or loss of signal or loss, which degrades your data flow. When assembling UTP cables, we utilize two distinct wiring methods depending on the devices we want to connect. First is the straight-through cable. This is designed to connect two different types of network devices, such as a computer to a switch or a router to a switch. The wiring order on NA and NB is completely identical following the T568B standard layout: white orange, orange, white green, blue, white blue, green, white brown, and brown. Second is the crossover cable. This is used to link two devices of the same type directly together, like a PC to another PC or a switch to another switch. For this, the pinots differ. NA follows the T568B standard, while NB is crossover to match the T568A standard. During the actual crimping process, core execution is vital. You must push all 8 copper strands firmly until they visibly bottom out against the very front edge of the plastic RG45 cell. A correct crimp indicator requires the outer protective sheet or cable jacket to be pushed far enough inside the housing so that the crimp wedge clamps down directly onto the jacket for strain relief. Stripping the internal wires too long is a fatal mistake that leaves the jacket outside the plug, making the wires loose, unprotected, and highly prone to breaking. Now that we have covered the theoretical hardware and wiring methods, we can put all these concepts to the test using Cisco Packet Tracer. On your screen, you can see the logical network topology that I designed for an enterprise environment, specifically for PT Suparma Tbk. Let's briefly break down the network architecture. At the very top, we have router 1 and 1841 model, acting as the main gateway to route traffic between networks. This router connects directly down to two primary switches, dividing the infrastructure into two major operational branches. On the left branch, the switch aggregates the workstation for the admin department, PC admin 01 through 05, and the finance department, PC Finance 01 through 05. On the right brains, the switch connects the workstation for the IT department, PCIT 01 through 05, and the general staff, PC staff 01 through 05. In addition to standard workstation, the right side of the network implements resource sharing by integrating two dedicated network printers, Printer Net 01 and Printer Net 02, allowing seamless printing access across the branches. By using Cisco Packet Tracer, we can validate IP addressing schemes, verify cable links, and test end-to-end data transmission across departments to ensure the entire network is completely error-free before deploying actual physical hardware in the field. To conclude our presentation today, building a wide local area network provides absolute advantage when it comes to connection stability, data security, and maximum throughput speed. A comprehensive understanding of the right hardware, strict adherence to crimping standards, and validating design through robust simulation, software like Cisco Packet Tracer are the ultimate case to deploying a reliable and highly efficient network infrastructure. That brings me to the end of my presentation on building LAN and wide networks. I sincerely hope this information proves valuable to everyone. Thank you so much for your time and attention. Let me close with Paramasanti. Om Santi 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 Om. And see you next time.